Hi everyone. The topic of this lecture is ventilation, and we're going to start out by discussing indoor air quality and how to measure ventilation before focusing down on kitchens specifically, and we'll look at how to size your kitchen ventilation equipment and the various different types of equipment that exist. So let's start by asking ourselves, why do we ventilate our homes? We do it in order to improve our indoor air quality and reduce indoor air pollution. We do it to remove moisture, a very important piece that goes hand in hand with that indoor air quality. And finally, we do it because we have to. It is a code requirement. So starting out with a definition, indoor air quality, which is commonly abbreviated IAQ, right, refers to the characteristics of the air inside buildings and structures, and it impacts the health, comfort, performance, and productivity of the people inside. It's very important because on average people spend 90% of their time indoors. In our society, we don't actually spend all that much time outside. We live and work indoors. And sometimes the indoor level of pollutants are several times higher than what they are outdoors. And so poor indoor air quality is an environmental risk factor. You've never thought of the air in your house as polluted? Well, what are all those pollutants? Here's a list of kind of the most common ones found in homes, starting with some particulates, that means teeny tiny particles, right? Such as pet dander, smoke, dust, right? And then we also include some toxins like mold and pesticides. Volatile organic compounds are also counted as toxic in our homes. Right? This includes paints, stains, adhesives, and some cleaning products. And then some very important indoor air toxins include carbon monoxide. So we worry about our natural gas equipment. And also radon, which is a naturally occurring gas that can creep into your home. Now that we know there's a problem, how do we fix it? How do we improve indoor air quality? There's 3 basic strategies. And the first one is the most energy efficient and lowest cost approach. So try this first. It's source control. You eliminate or reduce any sources of indoor pollution to improve the air quality. The next one is improved ventilation. All right, remember we said that often the outside air, it has less pollutants than the inside air. Therefore, we will try to bring fresh air in and exhaust the inside pollutants to the exterior. And our third tool to improve indoor air quality is filtration and air cleaning. This is going to remove pollutants from the air, and it's typically best for those particles, all right, the particulates. It generally doesn't remove any of the gaseous pollutants, those that are in gas form, like carbon monoxide, radon, and also cooking odors. Will not be reduced with filtration. All right, let's apply these 3 basic strategies to kitchen and bathroom design, starting with source control. Remember, we are eliminating or reducing the source of the pollution. Therefore, we're going to reduce excess moisture. And we're going to either reduce or eliminate the use of natural gas fuel. You'll also use low VOC and low or no formaldehyde products. If you're working in California, this is required by code. Moving to the ventilation piece, first we're going to design for natural ventilation, so allow for operable windows. And then we'll also provide mechanical ventilation. This includes hoods. It's recommended to put them over every cooking device, and also to install bathroom exhaust fans. Moving to the air cleaners, you can install portable air cleaners or purifiers for a single room or area, but typically your central furnace or HVAC system would be designed to filter the air in a home. Here in California, we've got some additional codes and requirements for ventilation of single-family homes. Starting on the left, your whole house. First of all, mechanical ventilation is required for all homes in California. This includes new construction, alterations, and large additions are going to trigger this requirement. Now, that's not a big requirement. For some smaller homes, your bathroom vent fan can be enough to count for mechanical ventilation for the whole home. Right? But for your larger and luxury homes, you're going to have a separate system. We also have some what is called local exhaust requirements for kitchen and for bathroom. First of all, mechanical ventilation is required in all kitchens in California. This can either be intermittent or continuous operation. The more common way to do this is intermittent, meaning you turn it on when you want it and you turn it off when you don't. There is a code required minimum of 100 CFM, and we'll see that in a little bit when we talk about how to size your ventilation equipment. In the bathroom, mechanical ventilation is required in all bathroom components. Again, this can be intermittent or continuous, and there is a code required minimum of 50 CFM. So CFM, I just used that term. What is it? How do we measure ventilation? There are two major units that we measure ventilation in, and they are related to each other. Let's start with air changes per hour, which is abbreviated ACH, and it is a measured amount of time. We've got 1 hour, and we count how many times the entire volume of air in that space is replaced. Right? Air changes per hour is typically used to measure whole house or continuous ventilation. When we're looking at one particular piece of equipment, one fan unit, for example, we would measure in CFM. That is the abbreviation for cubic feet per minute. And so that means in 1 minute's time, how many cubic feet of air, that's a volume of air, go past that fan. Or how you can think of it as how many cubic feet of air is exhausted from the room. Or you can even think of it as how many cubic feet of air is pulled to the outside. So both of these measurements, ACH and CFM, are measuring the velocity of airflow into a space or out of a space, doesn't matter, right? And they are related. So air changes per hour equals 60, because that's the minute versus hour transformation there. 60 times the CFM divided by the volume of the space. All right, everyone, we're going to pause this lecture here. We've just discussed indoor air quality. What is it? Why it's important? Some ways to improve it. And also, how do we measure ventilation in our home? Thanks.